Hello. In this video we'll be discussing linear equations. It's actually going to be 4 topics. Our first one's going to be the introduction, this one, and then our second one will cover solving linear equations. Then the next video will be solving equations that lead to linear equations and solving modeling problems, or what we call applications. Okay, so let's begin here. It says one method for solving an equation is to replace the original equation by a succession of equivalent equations. Equations having the same solution set until an equivalent equal to an equation with an obvious solution is obtained. So basically you begin with one equation, you manipulate it into successive equations until you can isolate the variable or find a way to get the x by itself, in other words. Alrighty, so that's how you would translate that little sentence into. Alright, so let's look at this. These are the procedures that result in equivalent equations. So these are the things you can do say on succession here. You can interchange two sides of the equation. In other words, you can replace 3 equals x by x equals 3. Let's talk about that a little bit. A lot of times people, when they're solving for the variable, they end up with the variable on the right side but not the left side. But since most people read left to right, when you see 3 equals x, it gets kind of nervous because you don't know what to do with that. But you just got to remember 3 equals x is the same as x equals 3. Alrighty, and x equals 3 is more common, so that would make more sense to most people. But when you see 3 equals x, it's not as much because, like I said, we read left to right. So when you see the x on the right side, you can always place it on the left side, just flip-flop. It's actually what we call the symmetry property. Okay. The second one is you can simplify the size of an equation by combining the terms and eliminating parentheses and so on. So for example, if you have x plus 2 plus 6 equals 2x plus x plus 1, you can take the 2 and the 6 and combine them by dropping those parentheses and get the 8. And the same thing on the other side, the 2x plus x, you can change it to 3x by dropping those parentheses. So that's just, but what this step is basically saying, combining like terms. You've probably heard that before, combining like terms. That's what they're saying in step 2. That's in essence what they're talking about. Okay, we can add or subtract the same expression to both sides of the equation. So if you have 3x minus 5 equals 4, you can add 5 to the left side, and you can, as long as you add 5 to the right side. And you've probably heard this saying, whatever you do to one side of an equation, you have to do it to the other side of the equation. That's in essence what we're talking about here. We're adding 5. The reason you'd want to do something like that is to eliminate the 5's in the negative 5 to plus 5 will be eliminated. So that's the purpose of doing that. But this step is basically saying whatever you do to one side of the equation, you do it to the other side. In this case, add 5. Okay? Or you can multiply or divide both sides of the equation by the same expression or same number. Alrighty? So you have 3x over x minus 1 equals 6 over x minus 1. X does not equal 1. You can multiply both sides of the equation by x minus 1. And again, this is kind of another way of saying whatever you do to one side, you have to do it to the other side. But I want you to be very careful when there's variables in the bottom, because when there's variables in the bottom, when you multiply that expression, x minus 1 on both sides, you have to remember x cannot be 1. And so if you're solving this equation and x turned out to be 1, then you would have to throw the answer away, because even though it may solve to that, it doesn't work for the original equation. So that's what we would call 1 is extraneous. So when a number appears to work, but it doesn't work because of a domain issue, you'd have to throw it away because that number is not allowed into the problem. Okay? If one of the sides of the expression is 0 and the other side is factored, then we can use the zero product property and solve and set each one equal to 0. So in other words, if you have x times x minus 3 equals 0, then x equals 0 or x minus 3 equals 0. It's called the zero property or the zero product property. Some people just simplify it down to that. Basically, if you remember, if two things are being multiplied and equal 0, then one of those things have to be 0. That's where that comes from. In other words, if a times b equals 0, then either a equals 0 or b equals 0. And so in this case, a is the x and b is the x minus 3. All right, let's move on. Here, okay, so we're going to get an example. Here we're going to solve the equation 3x minus 5 equals 4. That was the one that we kind of set up a while ago in that chart. So let's look at the solution. So we replaced the original equation by a successive equivalent equations. So what did we do a while ago? We added 5 to both sides of the equation. We add 5 to the left and we add 5 to the right. Okay? And then you drop the parentheses and the minus 5 and the plus 5 are gone. So I'm applying a lot of those properties we've talked about in the previous table. And so we get 3x equals 9. So there's 2 successions here. I added 5 and then I eliminated them. So 3x equals 9. So what we're going to do now is get the x by itself, divide both sides by 3, x equals 3, and we simplified that out. So the last equation, x equals 3, has a single solution x of 3. All these equations are equivalent. So 3 is the only solution of the original equation, 3x minus 5 equals to 4. Alrighty? So, for example, the first equation after 3x minus 5 equals to 4 is an equivalent equation to the second one. The second one is equivalent to the third one, and the third one is equivalent to the fourth one, and the fourth one is equivalent to the fifth one. So therefore, the first one is equivalent to the fifth one. So therefore, the solution for that equation is 3. Now, you don't always have to do what we're about ready to do, but it's a good idea to sometimes to check your answers on problems. So that's what we're going to do here, I believe. We're going to check it here. And we're going to check the solution by substituting 3 back into the original equation. So the original equation was 3x minus 5 equal to 4. So if we put 3 in, we get 3 times 3, which is 9, and then 9 take away 5. They got these question marks on there, whether they're equal to 4 or not, and it does. 4 does equal to 4. So it does check out that 3 is the solution. And I realize a lot of you guys are saying, yeah, this stuff is easy. Well, this is chapter 1 of section 1 in college algebra. A lot of this is review. So don't get too, pumping your chest out real big, because this is review from Math 101 actually. And so this is something, it's, something where we'll get a lot more complicated than this in this course. So it's a good idea to look at these though right at the beginning, just to get your confidence up, but don't get too much confidence. And for those who hadn't seen math in a long time, like for 2 or 3 years, this may not be too easy for you because of the time span between the time you took it then and now. So some of you guys will find this quite easily done because you've had a math class not too long ago. Some of you guys, it may have been a few years, and so this maybe it's review for you as well. You wouldn't be in this course, but that review time span could be a lot longer. So either way, all righty. So steps to solving equations. Okay, you list the restrictions of the domain of the variable. So the first equation up there, 3x minus 5 equals 4, there are no restrictions. It could be any number you want it to be because there's no domain, there's no variable in the denominator. There is no denominator. Okay, simplify the equation by replacing the original equation by a succession of equivalent equations, much like we did in the previous, using the procedures listed earlier. If the result of step 2 is a product of factors equal to 0, use the zero product property and let each factor equal to 0, and in this case procedure 5, and then check your solution. Now step 4, check your solution, sounds good, and it's always a good thing to do to check your answer when there is a problem that could have a domain issue. In other words, when we have a denominator, it's always good to check those because that number may not work. But a problem like this previous example, 3x minus 5 equals to 4, you're not checking for domain issues on this one. You're just checking to make sure the number works. So in that regard, if you're confident in your work, you really don't need to check it. But if you always have time at the end of an exam, it's always a good idea to do that. So, all right. So that concludes this introductory video of Chapter 1, Section 1. Our next one will cover solving a linear equation in a little bit more detail. All righty? Have a good day. Have any questions, as always, in this course, if you have any questions, you always contact me. There are other videos at hand, but contact me by email is a good way to alleviate some issues. All righty? Have a good day.